Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.71. While solving this problem, we will be using current divider rule. Basic equations for the calculation of current I1 and I2 for this particular circuit using current divider rule is provided here. Now move towards the problem. Exercise problem number 2.71. Find current I0 in given below figure. This is the circuit diagram of given problem. In this network, we have to find the value of current I0 inside this branch. So without wasting time, let's proceed towards the solution. In this network, only one parameter is required, that is current I0 through this branch. So rest of circuit will be simplified in order to make calculations easy for current I0. These two resistances are connected in parallel connection and both have same values. So their equivalent resistance will be calculated using this equation. R equivalent is equal to R divided by N. Here R is the value of a single resistance. In our case it is 12 kilo ohm and N is the number of same resistances connected in parallel connection. In our case N is 2. Place values inside this equation. R equivalent of these two resistances will be equal to 12K divided by 2. Divide 12K with 2, answer will be 6 kilo ohm. So we can replace these two resistances with a single resistance having the value of 6 kilo ohm. Modify the circuit. Now these two resistances are converted into series connection, so we can find their equivalent resistance and replace that resistance with these two resistances. Their equivalent resistance will be equal to the sum of both resistances. R equivalent of these two resistances will be equal to 12 kilo ohm. Modify the circuit by replacing these two resistances with a single resistance having the value of 12 kilo ohm. Circuit is simplified. Now we can apply current divider rule to calculate the current of this branch. Before applying current divider rule, first we have to label these branch currents. This branch current will be labeled as I1 and this branch current will be labeled as I2. We are interested to calculate the value of current I1 because it will be equal to current I0. So the current divider rule equation for the calculation of current I1 will be I1 is equal to R2 divided by R1 plus R2 multiplied by I into T. In this equation, I into T is total supplied current. In our case, it is 12 milliampere. R2 is the resistance of opposite branch. In this case, it is 12 kilo ohm. And R1 is the resistance of same branch. It is also 12 kilo ohm. Place values inside the equation to calculate the value of current I1. That will be equal to 12K divided by 12K plus 12K multiplied by 12 milliampere. Take the product of 12 milliampere and 12K, it will become 144. K will cancel out with milli and the sum of 12K and 12K will become 24K. Now divide 144 with 24K, the answer will be 6 milliampere. So the value of current I1 inside this branch is 6 milliampere and this same current will be equal to I0 because of same branch. So we can say that the value of I0 inside this network is 6 milliampere. So this was exercise problem number 2.71. Thank you. See you again in next video.